From the operating system running on your computer right now to the biggest, most epic video games on the planet, there's one programming language that's been a quiet powerhouse for decades. Today, we're going to dive into the fascinating origin story of C++, a language that, no exaggeration, truly shaped our digital world. So here's how we're going to break it down. To really get C++, we have to start with its legendary predecessor, C. Then we'll see how it evolved, we'll unpack the powerful, kind of risky philosophy at its core, see where it totally dominates today, and finally, we'll tackle the big question. Is C++ a relic, or is it still a giant? All right, first things first. Before you can even talk about C++, you have to talk about the language it grew from. So let's turn back the clock and talk about C. What's just wild is how quickly C became so essential. It was cooked up at the legendary Bell Labs back in '72, and just a year later, it was used to rewrite the entire Unix operating system. Now, that was a huge deal. It basically tied the fate of C to the success of Unix, and that set the stage for decades of dominance in systems programming. So what was the secret sauce? What made C so revolutionary? Well, it all came down to its design. Its creator, Dennis Ritchie, wanted a language that was lean, fast, and gave the programmer an insane amount of control, especially over memory. But the real game changer? Portability. See, before C, programs were often stuck on one specific type of computer. C let you write your code once and then recompile it to run almost anywhere. For the time, that was a massive leap forward. So C was incredibly powerful, for sure. But another researcher at Bell Labs, a guy named Bjorn Strustrup, he had some ideas on how to make it even better. And this, right here, brings us to the birth of C++. Starting way back in 1979, Strustrup began building on top of C's foundation. And the key here is that he wasn't trying to replace C, he was trying to extend it. That's exactly why you'll often hear C++ called a superset of C. It takes all that power, all that efficiency of C, and then adds a whole new layer of features. And the single biggest new feature he added was support for object-oriented programming. Okay, think of it like this. C's approach is like following a recipe, right? It's step by step, it's linear, it's straightforward. Object-oriented programming, that's more like building with Legos. You create these little self-contained objects like a wheel, an engine, a seat that have their own data in functions, and then you snap them together to build much, much bigger and more complex things. It was a total paradigm shift. And C++ didn't just stop there. It has been officially evolving ever since. The first international standard dropped in 1998, but the 2011 update, C++11, was a monster. It's really considered the baseline for what we think of as modern C++. And since then, the language gets a major refresh every 3 years, keeping it powerful and totally relevant. Okay, so we've got this super powerful, constantly evolving language. But what really truly defines its personality? Well, it all comes down to this one core philosophy. Trust the programmer. This, right here, this is the soul of both C and C++. The language is built on one fundamental assumption, that you, the person writing the code, know exactly what you're doing. But let me tell you, that trust is a double-edged sword. It gives you incredible, wonderful power to create amazing things, but it also gives you the power to break things in the most spectacular ways. It's a high-wire act, for sure. So let's break that down. C++ is designed to get out of your way. It gives you direct, low-level control and will almost never stop you, even if you're telling it to do something that seems completely illogical. It just assumes you have some clever reason for it. Now, for an expert, this is liberating, but for a beginner, it can be an absolute minefield of potential bugs and crashes. So, with this whole philosophy of high power and high risk, where does a language like C++ even fit in our modern world? Well, it turns out this philosophy makes it the perfect tool for some of today's most demanding jobs. The answer is actually pretty simple. Anywhere that speed and control are absolutely non-negotiable. When you have to squeeze every last drop of performance out of the hardware, C++ is very, very often the tool for the job. And you see its impact everywhere. We're talking about the engines behind blockbuster video games, the super-fast algorithms in high-frequency stock trading, the real-time systems that run factories and transportation, and even complex AI and neural networks. These are all fields where a millisecond can make or break everything, and C++ delivers that raw speed. Okay, so we know it's powerful, but with so many newer and frankly easier-to-learn languages out there now, it's fair to ask a question that comes up all the time when people talk about C++.
Yeah, people have been asking this for years. I mean, is this classic language finally on its way out?
Well, the data gives us a really clear, really simple answer. Absolutely not.
In fact, if you look specifically at compiled languages, those are the ones that get translated directly into machine code for max speed, you see that C++ is consistently neck and neck with C# for the top spots, right behind Java. This isn't some niche language, it is a fundamental pillar of the programming world. So the key takeaway here is that C++ isn't just surviving, it's actively thriving. Thanks to those constant updates, a massive ecosystem of libraries, its complete dominance in the huge video game industry, and the fact that it's a cornerstone of computer science education, yeah, C++ isn't going anywhere. So there you have it. We've seen that C++ is a language built on this philosophy of trusting the programmer with incredible power, with direct control over the machine. It's not a relic. It's a living, breathing tool for building some of the most demanding software in the entire world. Which really just leaves us with one final thought. The language gives you ultimate control. The only question is, what will you build with it?